Okay, good morning class. Okay. And also good morning to Mr. Jim Lau Si Hao. Okay. So okay, so today, right? We continue our lesson. Okay, so on Tuesday, right, I already teach you how to calculate the acceleration, right? Using the ticker tape, okay, and then how you want to find the velocity, okay, velocity, and also how you want to find time, okay, and also displacement using the ticker tape, okay. All right. So now, okay, so we're gonna analyze, okay, the ticker tape, the motion of the ticker tape, okay. So let's say this is the ticker tape, okay. All right, so you can see the distance, right? The distance between the ticker tape, the distance between the two dots is same, right? So we're using the formula, right? V is equals to S over T, right? So you can see here the displacement is same. So mean if the displacement is same, the velocity is also must be same. Okay, so this one is a uniform velocity. Okay, uniform velocity, or sometimes we call it as a zero acceleration. Okay, zero acceleration or uniform velocity. Okay, so any question you want to ask for this part? No. Okay, right. So we move on to the next one. Okay, so it's a constant velocity. Okay, so how about this one? Okay, so you can see from here, so this is the direction of the motion, and Tuesday I already told you, so let's say the direction of the motion is to the right, so mean this side come out first, right? So this dot come out first. Okay, so you can see here the distance is increasing, right? So V is equals to S over T. So when the displacement is increasing, the velocity also increasing. Okay, so you can see the velocity increasing here. So this one is increasing velocity, or you can say velocity increase. Okay, and also this one is acceleration. Okay, means the object is in the acceleration. Okay. Okay, next, how about this one? Okay, uniform acceleration. Okay, for this one, you can see the distance is decreasing, right? The distance is decreasing. So V is equals to S over T. Okay, and the direction of the motion is to the right. So mean this part come out first. Okay, so the displacement is decreasing. So means the velocity also decreasing. So this one is velocity decrease. Okay, so mean if the velocity decrease, so what about the acceleration? Anyone? Acceleration? What is the acceleration here? What is the acceleration here? Deceleration. Yes, very good. Okay. So deceleration. Okay, so if you calculate the acceleration should be in negative, right? So the value should be negative. Okay. Alright. So for this part, I want you to try to answer for number 1, number 2, and number 3. Okay, so please describe the motion, whether in moving in the constant acceleration, accelerate, or velocity increase, deceleration. Okay, so try to answer number 1, number 2, and number 3. Okay, and I will try to call three person. Okay. Don't forget to take attendance, okay? Yang and also Xin Mei, right? So you can see here the direction of the motion is to the right, right? So remember this part come up first. Okay. Yeah, I give you 2 more minutes for you to answer. Kelly, right? Sorry. Kelly will take attendance for. Yeah, you done? Can I call 3 people to answer the questions? Number 1 until number 3. Just see the distance between 2 dots, whether it's decreasing or increasing. And then you just try to use the formula. Okay, V is equals to S over T. So let's say the S increasing means the velocity increasing. And you already know if the velocity increasing, it means the object is accelerating. Okay. But this one you have to divide into 2 parts, for number 2 and number 3. Okay, so let's call number 1. Okay, number 1, Liu Xiong Wei. So what's your answer? Number 1, Liu Xiong Wei. Liu Xiong Wei, constant speed. Okay, constant speed, then how about the acceleration? How about the acceleration? No acceleration, okay. It's better for you to put 0 acceleration. Don't put no acceleration, okay? 0 acceleration, okay, constant speed, okay, and 0 acceleration, okay, right? Okay, number 2. Number 2, let's call Eng Yanzhen. Is it correct? I pronounce your name. Eng Yanzhen. Yes, okay. So what's the answer for number 2? Acceleration. Okay, acceleration. So anyone have another answer than acceleration? Maybe you have other answer than acceleration. Increasing velocity. Okay, increasing velocity. Okay. Other answer than increasing velocity, acceleration. Okay, no. Right. Okay, for number 2, you have to divide it into 2 parts. Okay. So because from here to here, right, you can see the distance is increasing. But at the second part from here to here, okay, right, from here to here, you can see the distance is constant, right? So means you have to divide 2 parts, okay, from here to here, okay. So this is A and this is B. Okay, from A part, you can see the distance is increasing, right? V is S over T, Okay, the distance is decreasing, so the velocity. So you can say here is acceleration. Okay, acceleration. Okay, and then for B part, this one is what? What happened to the velocity or the acceleration? What happened for this part, for B part? Zero acceleration, yes. Okay, zero acceleration because there is no change in, okay, there is no change in distance here. So means the velocity is same, okay. And if the velocity is uniform velocity means the acceleration is zero. Okay, acceleration, and after that is become zero acceleration. So you have to be careful. Okay, sometimes they will give you like this. Okay, some you have to analyze it. Okay, you have to divide it into two parts. Okay, so for this part you can see the distance is increasing, so velocity is increasing. So this one you can say increasing velocity or you can say it acceleration. Okay, and then for B part, okay, you can say this one is a uniform velocity or you can say zero acceleration. Okay, so mean the first part it move with acceleration, then after that it becomes zero acceleration. Okay, anyone want to ask teacher for number 2? Do you understand? Can you understand for question number 2? Alright, very good. Okay, so let's try number 3. So let me call someone. Wu Yilin. Wu Yilin. Wu Yilin, are you here? Yes, okay. So what's the answer for number 3? Zero acceleration, right? And then deceleration. Yes, very good. Okay. So number 3 also you have to divide. Okay. This one is it zero acceleration? Because I can see here is deceleration, right? Okay, maybe from here to here, right? The distance is same. Okay. Alright, so the first one is zero acceleration. Okay, for A. Okay, this one is B. Okay, so for A is zero acceleration. Okay, or you can say uniform velocity. Okay, and then for this part is become deceleration. Okay, deceleration. Okay, so for this one, move with zero acceleration. Okay, and then after that, deceleration. Okay, so number 3, anything you want to ask teacher? Are you clear? Yeah. Alright, for this part. Okay, so number 1. Okay, so remember the direction of the motion is still on to the right, so means this part come out first. Okay, and then you use the formula V is equals to S over T. Okay, and then you just see whether the displacement is decreasing or increasing. Okay, so for this part, the displacement is at first part is increasing, right, and then it become uniform, right, until here. Okay, so this is let's say A and then it's B. Okay, so try to answer this one. What is the answer for number 1? D. Yes, very good. Okay, very good. Okay, so for this one, you can see the velocity increasing. Sorry, the displacement increasing. So for A, velocity also increasing. Okay, so velocity increasing means it's accelerate. Okay, and then for B part, you can see there is no change of displacement. Okay, distance between two dots, okay, is same. So means the S is same. So if S is same, V also is same. Velocity is also uniform. Okay, so uniform velocity, or you can say zero acceleration. Okay, very good. So the answer for this one is the donkey. Okay. Alright, so this is the experiment. Okay, this one we do in the lab. Okay, when the school is open. Okay, so let's move to the last part for 2.1. Okay. Alright, so first, okay, you have to derive. Okay, how you have to know how to derive the equation of motion. Okay, so we have to learn about the equation of motion. So the first one is A is equals to V minus U divided by T. Okay, so this one we already learned. Okay, so how to form the first linear equation? So A is V minus U divided by T. Okay, then this one, okay, I change to this side. So this one is divide T. So when it goes to this side, it will become multiply T, right? Multiply by AT. Multiply by T, so it will become AT. Okay, so V minus U. Okay, and then V is equals to, okay, this one, negative U. If you change to this side, it will become U plus A T. Okay, so this is how you get the first equation. Okay, are you clear for the first one? Okay, so this is the first equation. Okay, alright, for the second equations, okay, so displacement is equals to average velocity multiplied by time. Okay, so we already know V is equals to S over T. Okay, so mean S is equals to V times T. Okay, so this is how they get this equation. Okay, V multiplied by T. Okay, V multiplied by T. Okay, since this one is average, right? So mean average, the initial velocity have to add by final velocity and you have to divide by 2 because you want to find the average, right? So initial velocity plus final velocity and you divide by 2 and then you multiply by time. Okay, so this is how you get the second one. Okay, so S is equals to U plus V and then you divide by 2 because you want to find the average and then you multiply by T. Okay, and then this one, take out the 1 over 2, so it will become like this. Okay, so this is the second equation. Okay, are you clear about this one? Okay, okay. So how about the third linear motion equation? Okay, so we have a first equation that is V is equals to U plus AT. Okay, and then we have a second equation that we just derived just now. S is equals to half U plus V multiplied by T. Okay, so what you have to do, you have to replace the equation 1 in equation 2. Okay, so equation 1 into equation 2. So we already know V is equals to U plus AT, right? So S is equals to 1 over 2. Okay, and then U. Okay, so for this one, V, we replace with U plus AT. U plus AT. Okay, and then T here. Okay, U plus V times T. Okay, and then what you have to do, have to multiply, right? 1 by 1. Okay, so half. Okay, so this one is 2U, right? Plus 80 T. Okay, so 1 over 2. Okay, so 2U T plus 80 squared. Okay, so okay, right. So next part. Okay, so this one you have to, this one you can divide, right? Can divide. Okay, so what left is you can just cut it off 2 and 2 here. So what will be left is U2 plus half AT squared. Okay, you just multiply like this. Okay, expand it. Okay, half 1 over 2 multiplied by 2 ut. So this one you can just cut it off. So only left ut. And then this one half at square. So this is the third equation. Okay, are you clear? You want me to explain again for this one? Alright. Okay, and then for the fourth linear equation, so square the first equation. Okay, so v is equal to u plus at. This is the first equation. Okay, so you will get v square equals to u plus at square. Okay, and then you expand, okay, the equation, so you will get like this. Okay, let me show you. Okay, u plus at square. So actually v square is u plus at multiply u plus at, right? Okay, and then v square is u plus multiplied by u is u square. Okay, u plus multiplied by 80 will be u 80. Okay, and then this one also multiply become u 80. Okay, and then the last one is a square t square. Okay, and then v square u square. This one is plus 2u80 plus a square t square. Right? Okay, and then factorize it. Okay, so u square. Okay, so this one you can take out at, right? Okay, so 2a. Yeah, 2a. Okay, so you take out 2a from here. So it will be left ut plus half at square. Okay, so and then you already know, right? This one is actually equals to s, right? So plus 2a s. Okay, for this part is actually equals to s. The one we derived before, the third equation. This one. Okay, so this is this one. Then I change it to s. Okay, so I just factorize it and I know already ut plus half at square is actually equals to s. Okay, so this is the fourth equation. Okay, so this is the fourth equation. Okay, are you clear for this part? How to derive the fourth linear equations? Okay, actually the important part is how you want to use this formula. Okay, these four linear equation, linear motion equation. So how you want to use it to answer the questions. Okay, alright. So what is S? So S is a displacement. What is U? U is the initial velocity. What is V? V is a final velocity. What is A? A is the acceleration. And what is T? T is the time. Okay. So let's say for this one, for this question, so V is equal to U plus A T means you have must have U, must have T, okay, and also must have V and A, right? For the second equations, okay, you must have U, okay, you must have V, must have T, okay. So you have must have S and another one, okay. Then can find, then you can use this equation, okay. Right. For the next part, you have to find. I have to have S, U, T, and also A. Okay. So you can find. You can use the third equation. Okay, and then the last one, okay, must have V, must have U, and also must have A and S. Okay, so let's try to answer a few questions. Okay, so I answer first the first one. So they said the car accelerates from rest. So means from rest, the initial velocity U is 0. Okay, and from rest to 25 meter per second. So means 25 is V. Okay, 25 meter per second is V. So in how many seconds? In 4 seconds. Okay, so the question asks you, okay, to find the acceleration. Okay, so you have to see the equation that will be given. Okay, so I just put here. Okay, V is equal to U plus AT. Okay, and then second one is S is ut plus half AT square. Okay, and the third one is v square is equals to u square plus 2as, and then the fourth one, the last one is half u plus v, okay, times t. Okay, so from this question, you have to find acceleration a. So which equation that I should use? Number one, number two, number three, or number four? Yes, number one. Okay, so number one means this one. V is equals to u plus 80. Okay, so V is 25, U is 0, A you need to find, time is 4. So 4A is equals to 25. Okay, so A is 25 divided by 4 is 6.25 ms negative 2. Yes, very good. Okay, 6.25 ms negative 2. Okay, so make sure you put the unit. Okay, make sure you put the unit, and also don't give answer in fraction. Okay, so never give answer in fraction. All answer must be in decimal point or whole number. Okay, alright. For number two, please try. For number two. Okay, so when a racing car passes through on a straight track, its velocity is 40 ms negative 1. So after 3 seconds, the racing car achieved the speed 50 meter per second. Calculate the distance, calculate the displacement travel. Okay, so you take out what's the information give. Okay, what is the question give, the information from the question that you can get, you take it out first. Okay. What is the U here, what is the V here, right? And then the T, okay, and then you have to find S, right? Sometimes they didn't put displacement, they put distance, or sometimes they put length, right? So all of that is actually S, okay, because they use the same unit, right, in meter, okay? So doesn't matter, okay, doesn't matter if they put displacement, length, distance, or actually that one is S, okay? 135 meter. 135 meter. Okay, so actually what's the formula that you use? Number? Number what? Okay, number 4. Okay. So straight its velocity is 40 ms negative 1. So means the U here is 40. Okay, after 3 seconds, so T is 3. Okay, and then the racing car achieved the speed 50 meter per second. So means the V is 50. Okay, and then you have to calculate the displacement S. So S is half U plus V K T. Okay, make sure you write the formula that you use. Okay, sometimes I already told you before, there's a marks. Okay, there is a mark for you if you put the formula. Okay, so half U is 40 plus 50, and then multiply by 3, so you get 135 meters. Okay, correct. Okay. Number 2, you use number 2. Oh, you mean the first one I gave is number 2, right? Okay, for this one, you have to find A. See, start his run from rest. See, I already told you from rest, what is the initial velocity? And maximum velocity is the V. Can we call someone to answer the question? Yi Qing Yang. Yi Qing Yang. Yes, okay. So what's the answer? Qing Yang, can you calculate the answer? Qing Yang, 10.44. Okay, thank you. Alright, so the 100-meter man world record holder Usain Bolt, okay, start his run from rest, so means U is 0. Can achieve his maximum velocity after he accelerated uniformly for 9.58 seconds. Okay, 9.58 seconds means T is 9.58. Okay, and then you need to find the acceleration A here. Okay, and it give you the displacement, the S is 100. Okay, so this one, oops, okay, S is 100. Okay, U is 0. A is, sorry, A you need to find, and T is 9.58. So this one use S is equals to UT plus half AT square. Okay, so U is 0, AT is 9.58 plus half KA you need to find. AT square is 9.58 square. Okay, then the S is 100. Okay, so this one you have to try to calculate 9.58 square. Okay, divide by 2. Okay, so we will get for 45.89 A. Okay, and then you just divide 100 divide by, you will get 2.18, right? Yeah, the answer is 2.18. Anyone get same answer as me? Qing Yang, what formula did you use before? Are you using the same formula as me? Are you using the same formula as me? Qing Yang? I thought it was velocity. For which part is velocity? 9.58 is a velocity? You thought 9.58 is a velocity? Or you thought they want to find the velocity? You use this formula, right? What formula did you use, Qing Yang? My calculation was out. So are you clear now? How do I get 2.18? Yes, okay. Right, so let's see question number 4. Hmm. He said Maria rides a bicycle at a velocity of 8 meter per second. So she brakes suddenly and stops after a distance of 2 meter. What is the acceleration of Maria and her bicycle? Okay. Write down all the info that question gave. Okay, so let's say this one you already know V, you already know U, and you have a S already. So you can see here it use two distance, right? So distance you can still consider it as S. Even we know that S is actually the displacement, right? But for this one, we just ignore the direction of motion. Okay, we just want the magnitude. Okay, what is the acceleration of Maria and her bicycle? If you 2 more minutes, okay, then I will call someone to answer the question. Okay, so let's call someone. Hmm. Eun Ki Hao. Eun Ki Hao. Is it correct? I pronounce your name. Eun Ki Hao. Eun Ki Hao. Are you there? Eun Ki Hao, are you there? Hello? Hello, Eun Ki Hao. Okay, maybe he's doing something else. Okay, I call another one. Lo Chi Seng. Lo Chi Seng, are you here? Lo Chi Seng. You can open your mic and also you can just answer in chat room. So no. No answer. Yes, wait, okay. See, just put wait, teacher. If not, I will think you do something else during my class. Okay, we wait for Chi Seng answer. So which one is you and which one is V? V is 8. Okay, V is 8. Okay, Jisen said V is 8. Okay, and then is that your answer? V is 8. Acceleration should be 4. Okay, so let's try to answer. Okay, Maria rides a bicycle at a velocity of 8. Okay, and then it said she brakes suddenly and stop. Okay, so means the final velocity should be what? The final velocity should be 0 because when you push the brake, of course the bicycle will stop, right? So means the V is actually 0. Okay, V is actually 0. That means the 8 ms negative 1 is actually U. Okay, yeah, initial, very good. Okay, and then the distance is 2 meter. And then the question want you to find acceleration. So use V square is equals to U square plus 2AS. Okay, and then V is 0, U is 8 square plus 2, A you need to find, and S is 2. Okay, so 0 here, this one should be 64, okay, plus 4A, right? And then this one you change to this side, it become negative 64 equals to 4A, and A is negative 16 ms negative 2. So mean negative, it decelerates, right? Okay, yes, so the answer is negative 16 ms negative 2. Very good. Okay. Chiseng, are you clear about this one? Chiseng, are you okay for this one? For this one, can you understand how? Alright. Actually, for 6, 7, and 8. Okay. 6, 7, and 8. Okay, I want you to do as a homework. Okay. I want you to do as a homework. Okay, so let's see question number 9. Okay, question number 9. Okay, so please try to answer first. 6, 7, 8 is a homework. Make sure you go and take the module, okay, at the guard post, okay, at the guard at school, okay, for those who cannot print. Okay, because I made like extra copy, okay, so for you, that first, when you first you write your name, you want to print, right? And then because I know this one, they got so many slides, so you want to change, you want to take the hard copy from me, so you can just go to school. I made an extra copy for you, okay? You can take anytime because the card is 24 hours. Okay, you can go and take at night also. Okay, question said a car moving with a constant velocity of 40 ms negative 1. The driver saw an obstacle in front and he immediately stepped on the brake pedal and managed to stop the car in 8 seconds. Okay, and then the distance of the obstacle from the car when the driver spotted it was 180 meters. How far is the obstacle from the car after it stops? Okay, 80 cm. Okay, Kai answer 80 cm. Any other answer? 160 meter, 20 meter. 160 meter, 20 meter, okay? Any other answer? 20 meter, 80 meter. Okay. 80 meter, 20 meter, 160. Okay, so let's see the real answer. Okay, so it says here a car moves with a constant velocity of 40 ms negative 1, right? And then when the driver saw the obstacle is step on the brake, so means the final velocity is 0. So V is 0. Okay, so this one 40 means this is a initial velocity. Right? And then he managed to stop the car in 8 seconds. So means T is 8. Okay, alright. So the next part is the distance of the obstacle from the car when the driver spotted it was 180 meters. So let's say this is a obstacle, right? So let's say this is an obstacle. So when he spotted, the obstacle is 180 meters. Okay, alright. So means this one you have to find the S. Okay, you have to find S here first. Okay, so how you want to find S? So you have to use the formula. S is half U plus V times T. Okay, so U is 40. Okay, V is 0 and the time is 8 here. Right. Okay, so you get 160 meter. Okay, so means, okay, before it stopped, it moved with 160 meter. And then after it reached 160 meter, the car stopped. Okay, so let's say the car travel until here. Okay, so it stopped after it travel 160 meter. Okay, the question asks how far is the obstacle from the car after it stopped. So mean the car is stopped right here, right? So what is the distance between the obstacle and the car is 180 minus 160, right? So the answer should be 20 meters. Okay. Can you understand? Anyone want teachers to repeat again? So the correct answer is 20 meters. Very good for those who got 20 meters. If you want teacher to repeat, just tell me. Okay, I will repeat for you. Right. Okay. So I will stop our class, okay, until here, okay. Then you can do, there's still a time like 10 minutes, right? So you can do question number 6, number 7 and number 8. Okay, and then maybe later on the evening or at night, I will upload, I will make a video, okay, for question number 6 and number 7 and 8, okay, and you can check your answer, okay. I will upload in the YouTube and I will give you the link in the group, okay. Alright, so thank you class, right? So if anything, you can text me or PM me later, okay. Thank you, bye-bye. Okay, have a nice weekend. Take care.
Bye.
Bye. Bye-bye.